In the deep cosmos of Andromeda, a galaxy emerges like ripples in the cosmic sea, where the dance and light of stars converge. Andromeda cradles a sense of mystery. With a soft glow, countless stars illuminate the path of the galaxy. The brilliance of starlight surpasses the galaxy, captivating our eyes with its beauty. The embrace of Andromeda is vast and profound, filled with the mysteries of the universe. The enigmatic tales of Andromeda, beyond the reach of our eyes. What lies in the future of Andromeda, revealing a different aspect of the cosmos? In the galaxy of Andromeda, where the spectacle of light and darkness continues. Today, in our 8th session of Introduction to Astronomy, we will explore the astonishing identity of the Andromeda Galaxy and contemplate the fate of galaxies. Subscriptions and likes greatly empower our video production. The Andromeda Galaxy is the closest giant spiral galaxy to our Milky Way, situated approximately 2.5 million light-years away from Earth. With a diameter of about 220,000 light-years, it is roughly twice the size of our Milky Way. With a diameter of about 220,000 light-years, it is roughly twice the size of our Milky Way. Andromeda Galaxy boasts around 1 trillion stars, with some being much brighter and younger than those in our own Milky Way. At its center lies a supermassive black hole, surrounded by a bulging region filled with stars, dust, and gas, as well as a flat, rotating disk. The spiral arms extending from the disk showcase the galaxy's history of star formation. Andromeda Galaxy is accompanied by several satellite galaxies, among which the largest ones include M32, M110, and M33, exhibiting elliptical or spiral shapes, formed through the merger of various primitive galaxies approximately 10 billion years ago. Andromeda Galaxy stands as one of the oldest galaxies formed after the Big Bang. In about 4.5 billion years, it is anticipated to collide with our Milky Way, giving rise to a new, massive galaxy. Information about the planets existing in the Andromeda Galaxy is still not well known. With approximately 1 trillion stars in the Andromeda Galaxy, it is presumed that some of them may have planetary systems. However, observing planets in the Andromeda Galaxy is extremely challenging. This difficulty arises from the fact that Andromeda is located about 2.5 million light-years away from Earth, making the planets appear very faint or even invisible. Research on giant planets within the Andromeda Galaxy is still in its early stages. In 2009, a candidate planet was discovered orbiting a star in the Andromeda Galaxy. This candidate planet, considered the first one found in the Andromeda Galaxy, is estimated to be a giant planet with about 6.4 times the mass of Jupiter. It appears to orbit a star known as M31 at 2008-12a in the Andromeda Galaxy, which is considered a new type of recurrent nova that explodes annually. In 2013, 2 additional candidate planets were discovered orbiting another star in the Andromeda Galaxy. These planetary candidates represent the second and third such findings in the Andromeda Galaxy, estimated to be Earth-sized planets with approximately 0.7 and 0.6 times the mass of Earth, respectively. These candidates appear to orbit the star M32001 in the Andromeda Galaxy, which is part of the satellite galaxy M32. It's important to note that these planetary candidates have not been definitively classified as planets. They were discovered using a method called microlensing, which utilizes the phenomenon of bending the light of a star when it aligns with a planet. While this method allows for the inference of a planet's presence, obtaining detailed information such as its size, mass, and orbit is challenging. Additionally, microlensing is a one-time event, making it nearly impossible to re-observe the candidate planets. To gather more information about planets in the Andromeda Galaxy, more powerful and precise observational instruments are needed. Space telescopes currently in development, such as the James Webb Space Telescope or the Louvre Space Telescope, could contribute to exploring the planets in the Andromeda Galaxy. I'll introduce some of the famous stars in Andromeda. While the Andromeda Galaxy is home to numerous stars, some stand out prominently. Here are a few of the well-known stars in the Andromeda Galaxy. Almach. Almach is the third brightest star in the Andromeda constellation, located in the southwestern region of the Andromeda Galaxy. It is a triple star system, with the primary star being a yellow giant, and the secondary stars consisting of a blue giant and an orange dwarf. Almach shines with a beautiful golden and blue hue in the night sky, easily distinguishable to the naked eye. Mirach. As the second brightest star in the Andromeda constellation, Mirach is situated in the western part of the Andromeda Galaxy. Mirach is a red giant, boasting a size approximately 100 times that of our Sun. It is one of the closest stars in the Andromeda Galaxy and serves as a helpful reference point for locating the galaxy. Eye of Andromeda. Positioned at the center of the Andromeda Galaxy, the Eye of Andromeda is a bright star resembling the eye of the galaxy. In reality, it is a binary system consisting of two stars, known as M31 Vij 0044379 Plur 4029236 and M31 VVG 0044380 Plur 4129236. These two stars orbit closely, exhibiting high temperatures and brightness. The Eye of Andromeda is influenced by the presence of a supermassive black hole at the center of the Andromeda Galaxy. Heart of Andromeda. This star, the brightest at the center of the Andromeda Galaxy, appears like the heart of the galaxy. The heart of Andromeda is actually a quadruple star system, comprising M31 VJ 004571 0 4123514, M31 VJ 004571 Plar 41 Sag 3508, M31 VJ 00445716 Plar 40123506, and M31 VJ 045718 Plar 411235R5. These four stars closely orbit each other, shining brightly and with high temperatures. The heart of Andromeda is influenced by the presence of a supermassive black hole at the center of the Andromeda Galaxy. I'll provide an explanation about the famous black holes in Andromeda. A black hole is a space where gravity is so strong that nothing, not even light, can escape. In the Andromeda Galaxy, there are two types of black holes: stellar black holes, formed by the gravitational collapse of massive stars, and supermassive black holes, located at the center of the galaxy. Stellar black holes are formed when a massive star, hundreds of times larger than the Sun, exhausts its nuclear fuel and undergoes gravitational collapse. While Andromeda Galaxy likely contains numerous stellar black holes, one particularly famous example is M32X1, located in the satellite galaxy M32. This black hole has an estimated mass of around 16 times that of the Sun and forms a binary system with a star of about 6 solar masses. M32X1 emits intense X-rays as it accretes matter from nearby stars, making it observable through telescopes. The black hole located at the center of the Andromeda Galaxy is known as a supermassive black hole with an estimated mass of approximately 140 million solar masses. This black hole exerts tremendous gravitational force from the galaxy's center, playing a pivotal role in the fate of the entire galaxy. Situated at the center of the Andromeda Galaxy, this black hole influences structures like the galaxy's spiral arms and plays a significant role in its evolution and star formation. The material surrounding the black hole rotates at extremely high speeds, generating powerful energy emissions that give rise to various observable phenomena for astronomers. These phenomena provide crucial clues for understanding the fundamental laws of the universe. Andromeda Galaxy also has stellar nurseries, akin to pillars of creation. A stellar nursery refers to clumps of interstellar gas and dust where new stars are being born. Among the many stellar nurseries in the Andromeda Galaxy, one particularly renowned one is the NGC 206 star cluster. Located in the spiral arm to the southwest of the Andromeda Galaxy, NGC 206 comprises around 4,000 stars. NGC 206 is much larger and brighter than our Milky Way's Orion Nebula and includes numerous young stars and H2 regions. Observable through telescopes, NGC 206 appears as a fuzzy patch in the night sky, forming part of the Andromeda Galaxy. The pillars of creation, on the other hand, exist in our Milky Way as cosmic dust pillars. These pillars, found in the Eagle Nebula, are accumulations of interstellar gas and dust where new stars are actively forming. The pillars of creation gained fame when first captured by the Hubble Space Telescope in 1995, and in 2022, the James Webb Space Telescope released an infrared image of them. The pillars of creation are situated approximately 7,000 light-years away from Earth and have a length of about 5 light-years. The name Pillars of Creation originated from a sermon by Reverend Charles Spurgeon in 1857, reflecting a sense of reverence for nature. The largest galaxy observed to date is not the Andromeda Galaxy, but rather a supergiant elliptical galaxy called IC 1101. IC 1101 is approximately 50 times larger than the Andromeda Galaxy, hosting over 100 trillion stars. Situated about 1 billion light-years away from us, IC 1101 is one of the oldest galaxies in the universe. On the other hand, the Andromeda Galaxy is the closest giant spiral galaxy to our Milky Way, located about 2.5 million light-years away from Earth. It has a diameter of approximately 220,000 light-years, roughly twice that of our Milky Way. The Andromeda Galaxy is home to around 1 trillion stars, with some being much brighter and younger than those in our own galaxy. I'll provide a detailed explanation of the collision between the Andromeda Galaxy and our Milky Way. The Andromeda Galaxy and the Milky Way are the two largest galaxies in the local group, gravitationally attracted to each other. Currently, the Andromeda Galaxy is approaching our Milky Way at a speed of approximately 120 km/s, and they are expected to collide in about 3.8 billion years. The collision between the Andromeda Galaxy and the Milky Way is anticipated to unfold through the following scenarios. Initial stages. As the two galaxies approach each other, their respective spiral arms begin to twist and stretch. The supermassive black holes at the centers of each galaxy start gravitationally attracting surrounding gas and stars, forming accretion disks. The accretion disks produce intense radiation, leading to the birth of new stars. First collision. When the two galaxies first collide, the stars in each galaxy scatter and the gases mix, triggering a vigorous phase of star formation. During this phase, there is a 12% chance that our solar system might escape the gravitational influence of the Milky Way, and a 3% chance of being incorporated into the gravitational field of the Andromeda Galaxy. However, due to the vast distances between stars, the likelihood of significant effects on our solar system is minimal. Intermediate stages. After the initial collision, the galaxies pass through each other, and their gravitational forces cause them to turn around for a second collision. The spiral arms of both galaxies transform into massive tidal tails and scatter into space. Additionally, the supermassive black holes at the centers of each galaxy approach each other, emitting strong gravitational waves. Second collision. When the galaxies collide for the second time, the stars mix and the gases merge, initiating another phase of intense star formation. During this stage, there is a high likelihood that our solar system will be relocated to the outer halo of the new galaxy. The supermassive black holes at the centers also merge, emitting colossal gravitational waves. Final stage. Upon complete merger, a new giant elliptical galaxy is born, known as Milkometa. This galaxy is called Milkometa and has a mass about 8 million times that of the Sun. This galaxy will appear like an elliptical galaxy, but will have a lower central density than existing elliptical galaxies. This galaxy may have a large halo of stars, left over from the spiral arms and tidal tails of the Milky Way and the Andromeda Galaxy. IC 1101 is the largest known galaxy in the universe, surpassing even the Andromeda Galaxy. It is about 50 times larger than our Milky Way, with over 100 trillion stars, situated approximately 1 billion light-years away. IC 1101 is considered one of the oldest galaxies in the cosmos. IC 1101 has grown to its colossal size by absorbing other galaxies, mainly consisting of aging yellow or orange stars. At its core lies a supermassive black hole with a mass equivalent to 400 billion suns. Currently, IC 1101 is in a state of decline, no longer producing new stars. The process of a galaxy's demise entails the cessation of star formation, gradual extinction of existing stars, and the possible loss of raw materials like hydrogen gas due to interactions, mergers, or other disruptive events within the galaxy. It's crucial to distinguish the concept of a galaxy's demise from the Big Crunch. The Big Crunch is a hypothesis about the ultimate fate of the universe, suggesting that if the gravitational forces due to matter are stronger than the expansive energy, the universe might contract back to a single point. This hypothesis is possible if the density of matter in the universe is greater than the critical density. However, current observations show that the density of the universe is much less than the critical density, and the expansion of the universe is accelerating. Therefore, the Big Crunch is considered a very low probability in current cosmology. When a galaxy dies, not only a black hole is left behind. The death of a galaxy refers to the process in which the galaxy no longer creates new stars, and existing stars gradually disappear. During this process, stars can die in a variety of ways. The smallest and coolest stars can survive for a very long time, becoming red dwarfs. Stars slightly larger than the Sun can cool slowly, becoming planetary clusters or white dwarfs. Stars hundreds of times larger than the Sun can explode into supernovae and become black holes or neutron stars. Therefore, in the process of a galaxy's decline, the exclusive dominance of black holes is not guaranteed. Black holes represent just one outcome in the diverse life cycles of stars, and not all stars end their lives as black holes. Additionally, black holes themselves are not eternal. Famous physicist Stephen Hawking claimed that black holes would gradually evaporate and disappear in a way called Hawking radiation. Because this radiation is so weak, it is expected to take billions of years for the black hole to disappear completely.